Sid, you here, bro?
Yes. Sorry for the delay. I can start presenting now. Are we ready?
I believe so, man. But first of all, yeah, I appreciate you jumping on and look forward to hearing about this. So, Sid, yourself, you are a backend engineer at Google. It seems like you've worked at some pretty amazing places so far, right? So, let's see, like Tesla, Meta, and a few others. So, we are super stoked to have you um, on board. And so, today we're talking about what RTP and media streams.
Yes. So I'm going to be focusing on video and audio streams and modern developments in the use of AI in conjunction with telephony and web conferencing. So, yes, I currently work at Google. Google very much owns me. That's part of why I was a little bit late here. It's hard to find, the time to step out for these things.
Yeah,
Hopefully, my connection remains stable throughout this. Please let me know if there are connection issues here.
of course.
Are you? Yeah. All right. I'll go on and plan to start beginning the presentation here. Uh, just a moment. Let me open the slide deck. All right, there we go. And so I'll go on and share. Sorry, yeah, mostly used to Google web conferencing. Just a moment. All right, go share slideshow mode. So, okay, here we go. Let's just go on and get to the presentation here. Uh, First, I'll give an overview of RPT and streaming media. So, why is it important to understand RPT and streaming media? Well, as ad spend on streaming platforms has grown during COVID, we're noticing that trend is continuing. So it's roughly doubled in the span of 2 years. And even though COVID has abated, we're continuing to see a growth in video streaming and web conferencing as a mode of communication. Uh, but you can't just use Zoom and Google Meet for all use cases. These platforms intentionally lock down their ability to create new meetings. Uh, Google Meet does not have an API for programmatically creating meetings. So, for instance, if you want to create a meeting and automatically connect to it, the only way to do that is to actually automate DTMF or phone touchpad button presses in order to connect to the meeting. They do this for security reasons, and as I'm going to discuss in the legal considerations section, uh, this is intentional. They don't want to have something called Zoom bombing occur anymore. And this means that there's actually a loss of interoperability between these platforms and your ability to automate the use of the platforms. So this means that if you want voice or video conferencing that fully fits your use case, you often need to build your own implementation of it. There was a news article on the 17th of this month about tracking pixels in the use of medical teleconferencing platforms. This is because some of these platforms also use a shared framework or platform, which didn't have the same sort of HIPAA compliant privacy considerations that are needed for medical teleconferencing. So this is why you need to understand these concepts in order to build your own implementation. One more note is there has been significant recent innovation in video audio codecs. So I did a survey of the release of new codecs, and just 2 days ago, they announced a new Opus codec. This is a codec anyone can use. It's non-proprietary, but it has a high clock rate, 48K. Uh, and there were other announcements of new codecs. So often you'll notice when new Bluetooth hardware is released, they'll often tout the use of these new codecs. This is a field where we're seeing innovation every day of late. So basically, in conclusion, if you haven't worked with audio and video streaming next, now is a good time to start. Uh, but one other topic I want to address here is PTS or PSTN, SMS, SIP, and STB. SDP. So connecting to your application to PSTN and SMS. So first, what are these acronyms? PSTN stands for all traditional hard phones. So this is any landline, any cell phone. If it's a telephone connection between two phones, that is a PSTN connection. SMS, we all know what SMS is. While this doesn't relate to RTP streams, both PSTN and SMS use something called a session initiation protocol, which I'll talk about on the next slide. So why are we discussing these when we've seen these technologies present for at least 20 years? Well, that's because there's a great deal of innovation, again, by applying AI. So and also the laws for both your web conferencing platform and traditional telephone calls will often overlap. So here are some examples of recent innovations. So AI chatbots can be used to fully automate call flows. So you've probably heard of Google Assistant being able to book reservations. This was announced maybe 3 years ago. I would say the number of applications we see like this, where we have AI fully automating a traditional phone call, are only increasing every day. And I've actually worked on a project like this, so I'm going to go over an overview of how you can build a software like that. So with the recent layoffs in tech, there's also a heavy emphasis on automated customer service. So essentially, we want to automate as much as possible. I've noticed this at Facebook, at Google as well. It's constant that we want to be able to have someone, and also we also on the other side of the equation have consumers who don't want to use a web form chat. They tend to be older customers. They want a phone number they can dial. So how do we solve this equation of less customer service representatives, but people who still want to use traditional hard phones? Well, you build bots that fully replace agents. Another innovation we're seeing here frequently is automated language detection. So for companies that have to consider a global market, it's often a pain point that you will have a customer calling from a country you didn't even expect to serve. But thanks to AI again, and thanks to bot automation and phone calls, it is now possible to do things like automatically detect what language a customer is speaking and then serve that customer. Again, this would have been extremely expensive if you were needing to hire human agents to do all of this, but now it's relatively cheap. All right, SIP and STP. So this is getting into the technical nitty gritty of how these sessions are initiated for PSTN, and also SIP calls. SIP calls are usually used for soft phone calls or things like Google Voice calls. So you need to know some core concepts here in order to make your life easier as you implement these. So one is the P charging vector. So once you call someone and it goes to the carrier, you generally have very little visibility into what's going on. The carrier has their own call logs, etc. And if there's an issue in connecting a call, the only way you'll be able to tell the carrier precisely which call failed to connect or what have you is the P charging vector. So I recommend if you are implementing the SIP, you should always use the P charging vector. For emergency 911 calls, a location is required because every emergency 911 call is supposed to go to its local dispatch center. And I'll talk about this more in the legal considerations section. You really want to get this right. One, because if you're out of compliance with something called Carey's Law, you can be fined quite a big deal of money. And also, if you implement it poorly without location data, you can end up having your call sent to a routing center, which can cost you $50 a call to correctly route your customer. So you really want to avoid costs like that. Sorry, accidentally clicked on one of my links. Sorry here, not used to. This is a RFC. I've included RFCs here. Sorry, let me try to get this back. I really should have practiced with Zoom. I'm sorry about this. Let's see. There's this bar at the top, so I can't quite see it. There we go. All right. Essentially, there are several RFCs that will be coming at the end of this slide here. I'll just go on and open that up. All right. So, the session description protocol, I'll go on and continue here. So the session description protocol also contains other relevant information you need to identify the call, such as who the caller originator is, but more importantly, for the sake of this talk, codecs. So this is another thing where obviously you want to prioritize higher quality codecs, but if you get this wrong, you can have failed call connection completely. So a lot of carriers, particularly globally, will only support low quality codecs such as 8K codecs, but you want to offer the highest quality codec so that when someone makes a call, they get the highest quality audio. So here are some open source libraries that can help you manage SIP. And here are some relevant RFCs. The reason I include the RFCs is, surprisingly, there are not a lot of libraries for this in all languages you may want to use. So, for instance, Java has a great Android core library for initiating calls, because obviously on the Android platform, this is a common use case. But for other Java backends, you may find you need to implement your own. So these are the core RFCs you can refer to implement this. So I'll go on and continue. I wanted to give a practical example of how we would implement this using everything I just talked about. So this is a SIP call. So you'll notice it says set local description. When you see the word description, that refers to SDP. The reason I use this example is because JavaScript has a native WebRTC and RTC pure connection interface, which you can use to initiate calls. So your code for initiating something like soft phone calling, or in this case, it's actual video conferencing, it's actually quite simple. Basically, you just need an element where you're going to render the video. This is the local video part. And at that point, you open the stream between user 1 and user 2. And at this point, both in this example, you'll probably have two different windows or two different tabs where one user sees the start call button, one user sees the join button. But thanks to these native JavaScript APIs, it's actually quite simple to implement something like WebRTC video conferencing. But the core concepts, such as STP or session description, are the same, be it a telephone call, WebRTC, etc. So this example I'm going to discuss at high level because it relates to a project I worked on, which it's covered by NDA, but the core concepts is something you can apply yourself. So this is an example of how to automate calls, specifically a PSTN call using bots. So first, the connection needs to be established. So the prior code pointer is an example of how that would be done. Basically, in RTC itself refers to live streams. You open the stream using a session description, and once the two callers are connected, you will generally want to have a means of transcribing your text. This is so that it can be consumed by something like a bot. Most AI or natural language processing algorithms will consume raw text. You don't want to have your bot focused on transcription when there are already libraries for this. So I've included a link to transcription libraries. An example that we often use at Google is called Cloud Speech API. You want to use this library to record text. As previously noted, there are privacy concerns here. It is legal for you to have transcripts that are used for temporarily for the sake of, say, a bot responding. It's only upon the moment of persistence outside of a session that legal considerations come into play. So you want to generate these transcripts, but out of caution, you probably want to do it on a temporary basis only during the life of the call so that you don't violate any privacy considerations around recordings or transcripts. Transcripts can be parsed and responded to using text to speech. So again, I've included open source libraries here. A common framework, again, that is used at Google is Dialogflow. So one more note, you can also have your bot automate DTMF digit presses. Again, these are the buttons that actually will exist on your phone. So the reason you want to do this is a lot of phone calling services have something called the IVR, interactive voice response, such as press 1 for reservations or say reservations. Uh, it will be much quicker for your bot automation whenever possible to use DTMF digits. So I've included a link. So just as in the previous example where there are native APIs in JavaScript, there's pretty good support for using DTMF. And then one more note, as I mentioned previously, once your call is, say, connected to a carrier, you lose a lot of visibility into the call. So you probably want your bot to be publishing events or making API calls to a service you own so that you can track the progression of a bot through a call. Otherwise, you may have a bot terminating abruptly, and you have no visibility into that because you cannot access those carrier logs easily. So legal considerations. I just want to go over this 911 calling example. So all applications capable of dialing phone numbers need to be able to dial 911. Even if you're working on the call center application and you don't anticipate your users will ever need to dial 911, you need to be compliant with this law. This is because this law was created when someone actually died when they tried to use a in-house hotel calling system to dial 911 while they were being attacked, and they weren't able to reach 911. Uh, you need to be in compliance with this, or else you can be fined heavily. But after working on a similar project like this, I've learned that there is an E933 calling service, which will allow you to test 911 calls without actually making 911 calls. It is a service provided by the government. Always make sure to include a location, as I mentioned. If you do not include a location, you may be charged $50 a call when you're routed to a general dispatch center. This is why smartphones will often manually ask you to give a location when you first set up that phone. That is because you may be making a call where your phone cannot provide precise geolocation data, which is a valid form of location you can provide to 911. So you always need to have a fallback as well. So all of this or this reference here sort of sums up all of this as well. It's well documented on several sites. HIPAA privacy and video conferencing. I accidentally clicked on an article here. Sorry, animation here. But this is a new article, as you can see, April 17th, 2023. Essentially, a lot of telemedicine platforms have tracking pixels. This can allow one to correlate a call with actual user. That's a HIPAA violation, and you can be charged heavily for that. You need to be vigilant uh, for tracking pixels. In our example, when I worked at a health company, is a lot of websites, they say, oh, we'll just drop in an analytics script, such as Google Analytics, because of course I want to be able to track the success of my site, but that can also constitute a HIPAA violation. So you need to be very careful about any scripts, tracking pixels, anything you have that is extraneous to the actual telemedicine call. So when you're logging phone call data, be vigilant of things like caller ID, phone number, etc., because again, that can constitute PII. And when you're working in medical context, PHI, that violation becomes more substantial. Similarly, recording consent laws vary by jurisdiction. Because in America, it is legal to have implicit consent for recordings, it's common for engineers to overlook this. However, you need to be sensitive to how laws vary by country. I believe in some European countries, you can be fined up to $1 million for violating these practices around recording consent. So you need to, again, be aware of which countries you're serving and make sure you're compliant in all of them. If you aren't sure you're compliant, you may even want to restrict your feature because, again, the fines can be quite hefty. These are just some recent examples of how streaming media platforms have been clamping down because of these legal repercussions. As I mentioned, Zoom bombing. Basically, it was too easy to connect to Zoom calls as an outside, visitor. So they got fined 85 million. Epic Games. This is a another specific legal consideration around children, because Epic Games serves children, and they were not doing anything to restrict dangerous content. They got fined more than $500 million, and then similarly, Facebook got fined $5 billion. Again, for sloppiness around privacy here. That concludes the presentation. I could go back to any specific examples if wanted. Uh, this is a field I've worked in for a while, and again, my specialization while working in this mostly has to do with bot automation during calls. So if there are any questions, please let me know, and I'm happy to answer.
Yeah, no, that was awesome, man. So I actually have a few. If you want to stop presenting there so I can pull you up as an interviewer. There we go. Yeah, so a couple is that. So, I get a lot of, so what do you see the future of like bot enabled calls being?
You can be quite sophisticated with these technologies, such as entering number presses, etc., uh, and even rendering speech. That's the way the Google Assistant software works. It will actually speak to a human being. So that is certainly the next frontier. Everyone's talking about Chat GTP. How can I use Chat GTP, etc.
Mm-hmm.
I think we're swiftly moving towards a future where we're going to have very human-like bot agents, which even have things like inflection when they talk to you, such that someone calling a call center won't even know they are talking to AI automation.
Right.
And again, I would say in the past 5 years, there's been a lot of work towards multilingual uh, natural language processing. A concept that I've noticed a lot of ML engineers are working on are hybrid language ML models. So in countries
Mm.
such as India, it's very common for people not to speak their, just one language. They often speak a mixture of English and another language. So I'm noticing there's a lot of innovation in not only language detection, but supporting two languages at once rather than just one language.
I see. Interesting. Now I have to ask the question. Like, are there any like safeguards or anything oversight, regulatory oversight being put in to help with like bot spam calls? Because I get a million of them, right? So any security things that that might be going on to help that?
So we did have a large initiative legally around that, like the do not call list, blocking numbers. But unfortunately, that proliferation you see is probably a symptom of all of these innovations going on. Uh, Anyone can, set up a PSTN calling application that integrates open source AI. And it's unfortunate that what you're observing is probably actually a symptom of these innovations. So
Mm,
it's possible we need more legal steps to be taken here. But besides, what was announced maybe around 10 years ago around Do Not Call, I'm not aware of any other restrictions on this.
gotcha. Now, is there any has there been any big steps forward, or when you're designing and working on this stuff, like how much are you paying attention to 5G, 6G, like the new like network bandwidth speeds? Are those is that enabling any new innovations that you weren't able to do in the past with particularly like lower bandwidth capabilities?
Yes, that's where the innovation and audio codecs come in. So, as mentioned, in a lot of countries outside the US, you can only expect 8K or 8 kilohertz audio codecs. I mentioned the I think it's 711 codec. But there's also A-Law codecs. These are lower quality codecs that have been in use for well over 20 years. But we're seeing every day a new codec being released, such as Opus at 48 kilohertz. So obviously 48 kilohertz versus 8 kilohertz, the audio quality improvement is quite significant. It's basically equivalent to listening to streaming music on Spotify.
Mm-hmm.
It's about as high quality as the human ear can detect, but of course it will continue improving. With 5G, this allows for higher quality codecs because essentially we have better networks that can support those higher clock rates and higher quality audio.
Gotcha. No, this has been fascinating and something that I did not know anything about. So it's great to hear about it. And yeah, look forward to keeping up to date and, seeing where the space goes.
Absolutely. I notice we have a few other participants in the call, maybe. Or is there anyone else here? What's the question?
Yeah, I don't know. I haven't seen any other questions come into the chat. But if anyone has any, then we'll send them over to you via email to get answered. But
All right,
yeah,
sounds good. I'm really sorry for connecting late. I got a
no,
new computer for this call, and they decided to crash an update right as I
yeah,
connected. So the
well,
perils of getting a two new computer for this. I'm sorry.
it's all good. Well, hey, if anyone wants to keep up with you or follow you, or are you on Twitter, LinkedIn, anything where
You
you
can
want to be?
find me on LinkedIn. Just look up my name, Sid LaLuz, and yes, you can find me there.
Awesome, man. Well, I appreciate it so much, brother.
All right, thank you.
See ya. And with that, Sid, so very interesting conversation. Yeah, I didn't know much about media streams or RTP, but it's like one of those like backbone infrastructure techs, right? That no one thinks about, but there is so much innovation on the horizon. So really, really appreciate him taking the time and look forward to seeing everyone on our next expert speaker series. Keith, do the outro.